I went to a private lab liquidation again and came back home with a densely packed car. I'd love to cover everything in its own video, but I just don't have the time right now. So I'll make a short overview, and if any of the exhibits strikes you as interesting, leave a comment and I'll consider making a separate video about that item. So the seller is an LED expert and I got a wide variety of his prototypes, constant current drivers and new old stock LEDs. The latter are quality parts, but since the LED industry has seen incredibly fast progress in the last years, they appear to have terrible performance by today's standard. Still, this massive aluminum chunk, turned and milled, is a thing of beauty. Look at those unreal shadows. Then there's this Swiss-made coaxial light source for inspection of difficult surfaces, such as highly reflective or curved ones. If you've ever tried to take a photo of a pair of glasses or a smartphone screen for an eBay listing, you surely know how difficult it is to get an accurate representation of small scratches and things like that. This device prevents reflections and glares by diffusely illuminating the surface coaxially to a camera or a viewer. It's rather simple, works with an array of LEDs, a diffuser and an angled one-way mirror. I stupidly left the desk lamp on, so this time it's not reflection free at all, but you get the idea. Taking it apart didn't reveal anything exciting either, as expected. Another LED thing I got is this manly flashlight. It's an old miner's lamp converted to 16 Cree X something LEDs. Serious heat sinking in this beast too. Just solid blocks of aluminum all the way through into a ripped heatsink on the back. But I managed to destroy all the LEDs anyway, by mindlessly powering it up without checking it first. Turns out the feedback potentiometer broke off, so the step-up converter went all the way up to its V-out max of about 80 volts. To make matters worse, it filled a 2.2 millifarad capacitor with that, and when I released that into the LEDs it gave a short flash, and that was the end of that story. Well, not entirely, because I'm going to try to fix this, of course. But generous application of JB Weld made this a little more difficult than I expected. Marketing says that JB Weld can withstand 260 degrees Celsius constantly, but from this aluminum surface that had obviously not been roughed up, I was able to cleanly sand it off at about 110 degrees Celsius. It was a rather unpleasant procedure though, so I'd prefer proper thermal compound over JB Weld anytime. That's how far I got with this project. Got a whole box of lenses too, but I need to buy new LEDs. Until then, I've got a 700 watt incandescent lamp with a cheap Chinese Thyristor dimmer. Ramping it up really feels like a sunrise in fast forward on your skin. But the experience is tainted because I'm somewhat afraid that it'll explode and shoot hot shards of glass in my face. And since the Q Thyristor has been dropped, here's a lifetime supply of those. Partially new old stock, partially water cooled, but all with a power rating way outside of my comfort zone. Although they all need a bit of control circuitry to trigger and a snubber to hinder them triggering themselves. This beautiful package has it all built in already. It's an AEG Thyristor power controller. 3-phase 500 volts, 45 amps. Costs more than $2,000 new, but on eBay it didn't even sell for $50. Maybe everyone's looking for something that's both easier to use and more powerful. Something like this 340 amp relay, for example. Yikes!
This is all very well.
But...
I'll stick to my guns.
And here they are. Big box of linear technology demo boards. Mostly LED drivers and step-up, step-down converters. All supremely designed and manufactured boards, of course. Number and size of the external components show how easy to use and energy efficient these DC to DC converters are. So in conclusion, I'd say these demo boards do exactly what they are meant for. Encourage buying LT components. But I've saved the best one for last. This is the LTC2440 24-bit high-speed Delta Sigma ADC and the appropriate USB interface board. With this combination you can easily set up a PC-based 6-digit DVM. I'm not using an external reference, so the absolute accuracy won't be that great. But with the high speed and zero latency of this ADC, some fantastic noise measurements are possible right out of the box. Otherwise, it's mostly cables. Some damn expensive optics, but I haven't investigated those yet. Huge power supplies. And aluminum. 60 goddamn kilograms of aluminum. I seriously doubt that I can use all that in one lifetime. Aluminum carpet, anyone?